these days, air temperature is something we can easily check on our phones or by stepping outside before deciding if we really need the t-shirt and sweater and puffy jacket and rain slicker and 2 pairs of socks and a hat and gloves. Whew, I'm sweating already. But air temperatures influence so much more than what we wear. Global temperature patterns have long affected cultures and community decision-making, and the landscape of plants and animals. Thousands of years of atmospheric observations and science have led up to all we know about a region's temperatures, and even how we think about a place. Like, if we know nothing else about the vast region we've long called Siberia, we know that it's cold, really cold. But there's more to it than that, just like there was more to the cultivation of bananas or the geoecosphere of Iceland. If you haven't already noticed, we'll be doing a lot of these deep dives to, go bananas throughout this series. And today we'll talk about ice and snow and regions like Siberia with temperatures that drop well below zero, but more broadly how the science and patterns of air temperatures affect geographical space, place, and human interactions with the Earth. I'm Tagir, and this is Crash Course Geography. As geographers, one of our fundamental goals is to answer the question, why is that happening here and not there? So while we could look up an exact temperature reading, we'd be focusing on a single data point and missing the larger connections that tell the story of the Earth. Like, Siberia can claim the lowest temperature ever recorded where people actually live, but that alone doesn't tell us why it has such an enduring fascination as inhospitable, forbidding, and a place of exile. Actually, humans have lived in Siberia for the last 40,000 years. It's been home to many nomad groups, is thought to be the birthplace of the Turkic people, and was part of the Mongol Empire in the 13th century before slowly coming under Russian control in the 16th century. All these habitats and different peoples have survived despite and because of Siberia's temperature. Yeah, it's really cold, but we can unpack that simple statement about the Earth's atmosphere and air temperature by using geography to explore the space, place, and human environment interactions. In fact, we can get a pretty good idea of Siberia's story and air temperature patterns with just 4 questions. First, what's the latitude of the place? As geographers, we want to see how temperature plays into the larger pattern of global weather systems, of biogeography, and as we'll see soon, climate zones and the global distribution of plants and cultural traits. And many air temperature patterns are tied to latitude. In our episode on the movements of the Earth, we saw how latitude is tied to how much insolation, or incoming solar radiation, each location receives. During the day, the short waves from the hot sun ping-pong through the atmosphere and absorb into the ground, warming the surface. At night, when a place isn't taking in insolation anymore, the cooler Earth is still radiating out long-wave energy, so air temperature drops. There's actually a time lag between our sunlight and air temperature cycles because the Earth takes a bit to warm up, which is why the hottest part of the day usually happens a little after 2 p.m. And this phenomenon is mimicked on a bigger scale throughout the year, as the Earth revolves and the latitude where the sun is directly overhead shifts north and south between the tropics of Capricorn and Cancer. So we get a daily and annual air temperature cycle. We can actually track these cycles and map the air, which is kind of mind-blowing when you think about it. We can't see air around us, but we can map it. These 2 isopleth maps, or maps that show the continuous distribution of data, show the average air temperatures around the world in January and July using isotherms, or lines joining locations that have the same temperature. In the course of a year, as the latitude where the sun is directly overhead shifts, the isotherms follow. Remember, places get less insolation as we move from the equator to the poles. The isotherms also show how air temperature varies season to season. At the equator, there's almost no difference between seasons. But the temperatures at the poles vary a ton. Basically, we can use higher latitude equals colder temperatures as a rule of thumb and dive deeper to better understand a place. Maps like these are one way we can expand on latitude temperature patterns. Even for a vast geographical region that makes up 3/4 of Russia's total territory like Siberia. It's big. Like, we're talking has 8 time zones big. Siberia spans all the way between 50 degrees and 70 degrees north latitude, which means it tips over into the Arctic Circle. On our January map, winter in the Arctic and subarctic brings plunging temperatures. Like, the frigid minus 50 degrees Celsius isotherm cuts across northeastern Siberia. The just under 1,400 people who call the town of Werkوی in the Arctic Circle home deal with average minimum temperatures as low as minus 57 degrees Celsius. So yeah, parts of Siberia are indeed very cold. The extreme cold of the high latitudes means that even though there's lots of land that can be farmed, the short growing season plus the mud created by melting snow and ice make agriculture difficult. Even building roads is a problem. So Siberia remains largely uninhabited except for small scattered lumber and mining settlements. The second question we can ask is, how far away is the place from the ocean or sea? On the isotherm maps, the greatest temperature difference from east to west happens where the isotherms leave large landmasses to cross the oceans. Let's follow the 15 degrees Celsius isotherm. It lies over central Florida in January. By July, it's moved farther north where it then loops into northwestern Canada. But the isotherms over oceans shift much less. Land has a low specific heat, or how much heat is needed to raise the temperature 1 degree Celsius. On the other hand, water has a high specific heat, so oceans need more heat for temperatures to increase 1 degree. Water can also store heat by moving it down to mix with deeper, colder waters through convection. So a really important factor for air temperature is ocean distribution. Places far from oceans tend to have a stronger temperature contrast from winter to summer. This condition is called the continental effect, or continentality. Siberia has extensive coastline and sits within the vast interior of the Asian landmass, which means it has inland areas with great seasonal temperature fluctuation and areas on the coast where the ocean keeps things more stable. South of the Arctic Circle, the high latitude of Yakutsk and its location in the continental interior means its annual temperature jumps from -45 up to 20 degrees Celsius. So it can be far below zero one moment and you're sipping hot honey tea. But several months later, it's warm enough to drink some iced kvass, which according to the power of the internet is like a refreshing soda, though I've never tried it. I still have to visit Siberia, so if you've tried it, tell me what you think. Both continentality and the ocean influence Siberia's climate significantly. Russia's Far East has a distinctive subregion with longer growing seasons and a milder climate because it's close to the Pacific Ocean. As we move southwest, the wetter climate of East Asia meets the continental climate of the Siberian interior to create a zone of ecological mixing. Coniferous forests mix with Asian hardwoods, and reindeer mix with Siberian tigers and leopards. There's actually great landscape and climate diversity within frigid Siberia. Our third temperature-related question is, what is the elevation of the place? At high elevation, or how high a point is on Earth's surface relative to sea level, there's less air to absorb solar energy, and we feel a drop in temperature. For the same less air reason, we also feel a drop in temperature at high altitude, which refers to the height of an object, like an airplane, above Earth's surface. Basically, highlands are always colder than lowlands. Mount Kenya is about 5,200 meters high and is located at the equator, yet is still cold enough to have glaciers. The isotherms around the Rocky Mountains dip down in both summer and winter. The effect is even more noticeable in the Andes Mountains in South America. The many mountain ranges in Siberia, like the Altai Mountains to the south or the ورکوی Mountains to the east, will be colder than the surrounding lowlands. They also mark changes in the ecosystems because of the difference in temperature and moisture that mountains provide. Like in many of these higher elevations and high latitudes, with cold temperature comes snow and ice, which go on to influence temperature in a feedback loop of sorts. The high albedo, or reflection of insolation, of the snow keeps winter temperatures low by reflecting much of the winter insolation back to space. The type of surface can even influence temperature on top of latitude, continentality, and elevation. This idea brings us to our fourth and final question. Is the place an urban area or a rural area? Cities across the world are actually trying to increase their albedo with green roofs, covered in plants, more trees, and painted white surfaces. The darker sealed surfaces of human-made urban environments absorb a lot of solar energy without also absorbing moisture. So we end up creating urban heat islands where air temperatures are several degrees higher than in the nearby suburbs and countryside. But there's more to solving urban heat islands than that. Let's go to the thought bubble. In modern-day Phoenix, Arizona, we're actually smack in the middle of the Sonoran Desert, which can get quite hot. A city, aka urban heat island in the desert, even hotter. Despite that, Phoenix is one of the fastest growing metro areas in the US. As the city sprawls into the surrounding desert, it's increasing its paved sealed surfaces, making it the fastest warming city in the US as well. Temperatures above 37 degrees Celsius are common in the summer, and like in other parts of the world, heat-related deaths are a public health issue. And as climate change increases heat in the lower part of the atmosphere, summers are projected to only get hotter and longer. On top of that, the effect of urban heat isn't evenly distributed because of land use, like the distribution of highways, parking lots, and parks. Measuring temperatures across various city spaces can reveal a 10-degree difference between neighborhoods less than 2 miles apart. For example, wealthier neighborhoods are usually well shaded with trees, while low-income neighborhoods are hardest hit by heat, meaning those communities suffer disproportionately from health threats due to extreme heat. Phoenix has introduced a program that treats heat readiness on par with climate change disaster preparedness. Plans include a return to traditional building materials like adobe, redesigning low-income neighborhoods with emergency cooling towers, increasing the city's tree canopy, and orienting new buildings so they shade sidewalks and courtyards, along with alerting residents with text notifications when a heat wave is imminent. But citywide measures can only do so much, and combating urban heat islands has to do with where and how resources are given to the communities that need them most. Thanks, Thought Bubble. Studying air temperature also means we have to ask questions about equity. How does temperature affect the people that live in a certain place? And who has access to the public services and facilities to stay healthy and go about their lives? We saw how latitude, ocean proximity, and elevation come together to make Siberia so cold that very little grows and few people live here. In the past, the search for valuable fur and minerals, which still continues, stimulated Russian expansion into the vast wilderness of Siberia. Today, melting sea ice in the Arctic Ocean from higher temperatures has opened up shipping lanes, which will bring increased trade and growth to the northern Siberian region. But it also adversely affects indigenous reindeer herders of the Russian Arctic. Delays in sea ice freezing disrupt seasonal migration routes, destroying a way of life and economy. The environment creates opportunities and challenges to which humans respond. But human-environment interaction is a two-way street. We'll keep examining these issues as we explore larger patterns of global climate and their impact on lives, both human and non-human. Many maps and borders represent modern geopolitical divisions that have often been decided without the consultation, permission, or recognition of the land's original inhabitants. Many geographical place names also don't reflect the indigenous or aboriginal people's languages. So we at Crash Course want to acknowledge these people's traditional and ongoing relationship with that land and all the physical and human geographical elements of it. We encourage you to learn about the history of the place you call home through resources like nativeland.ca and by engaging with your local indigenous and aboriginal nations through the websites and resources they provide. Thanks for watching this episode of Crash Course Geography, which was made with the help of all these nice people. If you want to help keep Crash Course free for everyone forever, you can join our community on Patreon.